talk over top of my recording here. Here's the questions for lab number 20, which deals with clocks and time, okay? How does the computer keep track of time? It's done through an SFML command. Yep, a variable. So it's called clock, the variable type, or the object type, I guess, because it has more than just values. So, question 1, part 1, SFML uses a simple object called clock. Create your own clock object, and then let it auto type so you can see what you can do with that object. No problem. I'll write the word clock here as if it were like a variable. I'll just give it the name C1. You can make more than one clock in the program. And then if you write C1 dot, okay, you can see, shh, guys, I'm recording. Hello. Shh, back row, back row. So you can see that obviously it has the word clock there, but the two green ones that you can call on this variable are get elapsed time, which is, it'll tell you this function returns the time since the last call to the restart command, and then there's also a restart command. So those are the two commands you can do for part 1. Part 2 asks you to try to output the clock, like in your loop somewhere, so that you can see what the time is that your program's been run for. So you could go cout like that, hit C1. It'll ask you what happens. It should error out, because cout is a C++ command and clock is an SFML command. They don't really know how to talk to each other. No one who built C++ language knows what a clock is. Like, they didn't, that's a separate part that someone else built so that we can make graphics. So we'll get a strange error, a really long one that basically says no match for the operator arrow arrow. Like, cout doesn't know how to print this out. Okay? So we cannot print out the clock's value yet, but there is a way. Question 3. The way to output time or use the clock is through a time object. Create a time object in your code. No problem. Call this one T1. It's capital time, by the way. And then it asks to let it auto type to see what commands you can do to that variable. There are 3 of them. They're the green ones. I guess there's 4. No, there's 3. Okay? Shh. Shh. There's, it'll print as microseconds, as milliseconds, and as seconds. Okay. Great. So it appears, question number 4. To output the time, you need to set your time object equal to the clock's elapsed time. Call your time object delta. Okay, no problem. Delta. I can do that. Somewhere in the loop, I will need to set delta equal to the clock's elapsed time. Okay. What's that? No. No, it should just work. As long as time is capital T. Because these are all SFML things, and we're already including SFML stuff. Great. So we've done that. Output the time you need to set the time. Oh, to output the time, you set it. Call your time object delta. What line of code would do this? Okay. How many times does your loop run if you let the time run for 1 second? I don't know how long the time's running, so now I'm going to cout it here. I'm going to write cout delta dot, I'll want to print it as seconds. Now if you look at that dot as seconds, it should be an integer. No, it's a float. Great. Okay. So I'm going to run my code for approximately 1 second. Try to quit it by pressing the escape key. Oh, it ran too fast. I didn't even really see it. You can see it's keeping track of the time, though, that my program's been open for. Feels about right. Okay. So, what does it say next? Create a counter variable in the while loop that runs until the time reaches 1 second. How many times does your loop run? Okay, so I'm going to make a counter variable. Int counter. I'll get it to start at 0. And I will say if delta.asSeconds, well, I don't want as microseconds. If it's ever less than 1, make the counter go up by 1. Sorry, too many brackets here. Counter plus plus. Okay, and then I'm going to see out counter so I can see what it's doing. Now, do I need to see out my time? Not anymore. So I'm just going to see out counter, see what happens. I got 59 that time.
Yeah, 1 before the second.
60 that time.
61.
58 that time. It's clearly around the number 60. It's not perfect. The reason why it counts 60 times per second is because of this line of code. Do you see that? When you call this line of code, it basically tries to stop this loop from running as fast as it can and tries to make this code all run 60 times per second. And it's not that hard to do because there's not much code in there. But if I say, if I don't put this line, we're going to get some really strange random numbers. It's just going to run as fast as it can at that given moment. 220. 200. Okay. 224. If I don't output it, it'll run even faster, I think. If I get rid of this cout and only put it in here. Oh, wait. Else cout. That's what I want to do. Else. Let's see how many times it'll run this time. Maybe like 1,000. It should be able to run that code really fast. 1,000 times. I ran my loop 1,000 times in 1 second. 1,032. 1,004. Okay. So that's my frames per second. That's how fast it can run it. I gotta keep it at 60 though. Makes the game smooth. Don't really need to run my game 1,000 times a second if my monitor can't even update my monitor 1,000 times a second, right?
So would it be 1,000 seconds then? Or how much would it be per
restart your clock at the beginning of each frame. How many times does your loop run? Okay, no. Restart your clock at the beginning of each frame. What time does it read and what does the time represent? Okay, no problem. So I'll just get rid of all this code where I'm running it for 1 second. I am going to, right here, I'm going to go c1.restart. But before I do that, I'm going to print out the time that it had. Delta.asSeconds. So it's going to print out, basically it's going to restart the clock, run the whole loop, and then figure out how much time it took to run that loop once. Now, if I'm a betting man, I'm guessing it's probably really close to the number 1 divided by 60, because I'm running 60 frames per second. So it should take that loop about 1 divided by 60 times to run in seconds. It's about 1.666 whatever, or 0.01666. It's my frame time. Okay. Is that close to that? It is. It's not perfect, though. Okay. It's never going to be perfect because the computer is
Not perfect.
it's not perfect at running. Like,
So should we say
yeah, there's
so?
always something going on in the background.
So it says you're going 160.
Yeah. So the time actually represents how long it takes to run a frame. Here's the last part, okay? If I want to move this shape, I would go somewhere in my code. I have this little shape, right? If I go shape dot move and I say 5 pixels to the right, it should just move my circle to the right. And it does, okay? Here's the problem. Let's say my computer gets really, really choppy and can only run 12 frames per second for a limited amount of time. What happens to the ball's speed?
Slower.
Yeah, it moves slower.
It looks choppier.
It looks choppier for sure, but it's moving physically slower. Would that be a problem in an online game? Would someone be able to cheat? Right? Let's say I set it to 1,000. What happens? Yeah, it goes quicker. Okay, so the problem with moving something is just with pixels is that it'll move however fast your frame rate is moving, which is really bad for a computer game, because if you have a bad computer, now you're actually going to physically move slower. You don't want to do that. So what computer games do is they find the time it takes to run and they give the thing a speed, and they actually just do like a little bit of a physics equation on it. So this is what it's saying. Sometimes the time variable can be used to move a sprite to avoid issues when the frame rate drops. Move a sprite with your time and a speed, and then set the frame rate to different values. So let's try that. Let's come up with a speed variable. I'll just call it 5 again. Okay.
James Charles. James President.
James Charles. So now I'm going to go, instead of move 5, I'm going to go move speed times delta. Dot as seconds.
James. James.
I probably want it faster than 5. I probably want it like 500. Because my delta is going to be really small.
Hi, James.
It's still too slow.
Your digression on this one.
So I'm going to maybe do 1,000.
I ain't saying what, but respectfully, it's kind of wrong.
It's weird that it flicks ahead like super fast. I might move this just in front of the... Maybe right here. It still like jumps ahead super fast. But don't worry about that for now. I know why that's happening. We'll figure it out in a second. But
Wait, so it should be shape.move then, right?
yeah, so okay. So let's go 60 here. The reason 1,000... There you go. There's 60 frames per second. Here's 5. Okay. Are they traveling the same speed? They actually are traveling the same speed. One just looks way smoother than the other. Here's 100. Okay. Here's 60 frames per second. It's the same speed. It's going across the screen at the same rate. Here's 30. But you can see what makes a game choppy when you go below 30. 30's okay, right? As soon as you start going below 30, you'll still go the same speed. All the physics will be the same. It just will look really choppy to you, okay? And that would not make a good game. Here's 15 frames per second.
Wait, why is it moving so slow when I have it on 60? What?
Okay, hold on.
Look at this.
It should be shape.move, and then speed times delta dot as seconds.
Yeah, it's it. Speed times.
Oh, speed is too slow. You need speed to be around 1,000. Because the delta is actually a really small number. If you set the frame rate, if you don't set a frame rate,
Wait, so that's the answer to question number
yeah,
7?
yeah.
7.
If you don't set a frame rate, it actually is really super choppy. Not 100% sure why it's doing that. But I'll think about that. I'll worry on that in a minute. And then the last question wants you to add like physics to it. Okay? So let's make this thing fall down, but let's make it speed up so it looks like it's accelerating. So that shouldn't be an issue. We'll move it in the Y instead of the X though. Like that. So it goes down. Okay, I'm gonna set my frame rate to 60 again because I break when I
Wait, that's question number. That's down. Down or down?
yeah, it doesn't change the speed, right? By putting that speed, that's way too fast actually. So now I'm gonna move it down instead of left, or instead of right. Okay. Might be a bit too slow to start. Okay.
Wait, why are you taking it down now?
Because the last question wants me to kind of simulate gravity. Okay. So I'm gonna move it down. But I'm going to simulate gravity by adding in a second term, plus 1/2 times some sort of acceleration. Maybe I'll make a variable for that. I don't know what this number is going to be yet, so I'll just make it 500.
Why is it 1/2 multiplied?
If you look at the lab, if you've never taken a physics course, your distance is always equal to your velocity times time.
Yeah.
Plus 1/2 times acceleration times time squared.
Say like, we have multiplied and then there's nothing after it.
So I was getting to that, brother. 1/2 times acceleration times time squared. Delta dot as seconds times delta dot as seconds. Let's see what this does. Does it look like it's going to pick up speed? Not there yet. Maybe we need a bigger number for acceleration. Let's try 5,000. Okay. 50,000 maybe. It's got to be a big number.
Try 100,000.
It's hard to really tell if it's doing it. Let's move it to the right a little bit as well. Maybe 10 pixels. I don't like that. Maybe we get rid of the restart. That'll make it really, really fast though. Oh, too fast? Let's lower the speed to like 30. And the acceleration to 300 maybe? That does? There. That's not bad.
How much?
Maybe the speed is 20 and the acceleration 200. You'll watch it pick up speed. See that? It's kind of acting like it's falling in space. Okay. There you go. What's going on back there, boys?
Wait, why is it so
No coding.
Why is it so slow?
Violated, sir.
Anyways, I'll stop it there.